Okay, so interval notation is going to be another way that we write inequalities. So it's kind of a shorthand. Math likes to have a whole bunch of different ways to basically describe the same stuff. So you probably are used to inequalities looking something like x is less than or equal to 5, or you could have compound inequalities, so it'll have two inequalities together with an or an and in it, or we could have like something like -2 is less than x is less than or equal to 7. So we can use our less than or equal to's. In general, when we talk math, we like to use less than inequalities when we're writing it in set builder notation. We're going to add a little bit more to it. If we can't get the numbers in order from smallest to largest using less thans, then we like to still keep things in smallest to largest, but then we use a greater than when we have to. And then we put the variable first when we're writing the inequalities. So set builder notation uses the inequalities kind of like we have, but we give a little bit more information. So the set builder is going to use the builder type notation, which means we've got the bracket, the braces. And we're going to start with what variable are you going to see? So it's x, and then there's usually a line there. So that part is just saying, okay, I'm giving you a set, I'm giving you directions of what you're going to see. The variable you're going to see in the problem is going to be x. So this is read x such that, and then you're going to give your rules. So that's where that inequality would be. So if we had the first one, we could say x is less than or equal to 5. So what you're looking at is the right-hand side of the set builder notation, which will give you that inequality that you have. If we were doing set builder for the second one, it would be the braces x, because that's the variable we used, such that -2 is less than x is less than or equal to 7. Okay. So that's just a little bit added to the set builder notation. Then you should be somewhat familiar with the graph, the number line graph. That is where we have just a regular number line. So it's a straight line. We're going to pretend I can draw a straight line. Ooh, that's not too bad. I could have used the line tool. And when I do number lines, usually I only put what I need on the graphs. So if I was graphing the first one, I would have a 5. And this is, remember, if we have the or equal to's, those are closed circles. So these are closed circles. Inequalities without the line underneath it, the or equal to's, are open circles. So these would be that. And we don't really worry, where they're pointing to is going to be which direction you shade. And it's really saying, okay, is the x, that variable that we have, is it smaller than the number that we're looking at or bigger? And keep in mind, number lines, negatives go here. So if I really wanted to label more, this would be negative infinity because it keeps going forever. And this would be infinity. If I'm graphing this first one, so I'm going to say that this is 1, I'm going to graph 1. That at 5, I would have a closed circle. And then this is read x is less than. If I'm looking at the inequality, that smaller part of the inequality is by the x. So that means I need numbers smaller than 5. So I would be shading this way. All right, so then if I do, I'm going to call the second one, I want to change colors, that this is number 2. So if I was graphing this one, I still have my straight line that I drew with my number line. In this case, I still have negative numbers are here. So everything gets smaller and smaller there. Positive numbers are here, keeps getting bigger and bigger to the right. We have the second problem. In this one, the two numbers that I have are a -2. -2 is smaller, more negative than the 7. So those are the two I have. -2 has an open circle. And 7 has a closed circle. All right, and in this case, x is in between the two, so my shading would be in between the two. And if I was looking at each one separately, the x is by the bigger part of this inequality. So it has to be bigger than the 2, so it's going this way. Those are bigger numbers. And then by the 7, x is on the smaller part of the inequality, so it's going this way, and actually my answer is all the stuff in between. Okay, so then what we do is math decides, oh, this is a little bit too much. Let's make things a little bit even more streamlined. So then we have interval notation, and this is just a shortcut way of saying the exact same stuff that we already have, but we do need some definition stuff. So parentheses, okay, these are this, they go with the open circles on a graph, and they go with the less thans or the greater thans. So it's just a new code of doing things. We have square brackets in interval notation, and they go with the closed circles. Okay, and they go with the less than or equal tos or the greater thans or equal tos. So those are the 2 ways that we're going to always say where we're starting and stopping. We do have a few other quirks with interval notation. So we will have negative infinity will always be paired with a parenthesis, because we can't actually write. Negative infinity is a concept. It's not an actual number. So it means the arrow that we have when we're graphing things. And then the same thing goes with if you have infinity, that is also going to have the rounded brackets. The other thing that we have is we have U is for or when we're saying it like we have in the notes, this is a gap in shading. Okay, and I ran out of room. So if we're doing the problems in interval notation, so question number 1 in interval notation, okay, if I'm looking at it, my shading goes, it starts at negative infinity. So it goes forever in that direction. So I would start at negative infinity. And it's going until I get to 5. And 5 has a closed circle on it. All right. In the example problems, we'll see some with gaps. So then if I was looking at number 2, when I'm looking at that, my shading is between -2 and 7. So I'm going from -2 to 7. At -2, I have an open circle, so it's rounded. And at 7, I have a closed circle, so it's the bracket. I can do it from the step builder notation as well, but I have an easier time doing it from the graph. So whichever works for you, just know that they're all 3 ways are the exact same information. You just have to translate from one to another. All right, so step builder notation. So yet again, these problems, we're all seeing variable x. We've got a few different situations where we have it. If I'm looking at the numbers, they are in smallest to largest, left to right for all of them. So we're just going to put these on the graph. All right, so for the first one, we have -7 and 3. So we have -7. -7 is by the less than symbol, so doesn't have the line underneath it, so it's going to be an open circle. So open circle. X is in between. I've got till 3, and 3 has the or equal to. It's got the line underneath it, so it's a closed circle. If I really wanted to think about it, I could be doing my interval notation at the same time, but I'm going to do it one at a time. And then my X is in between these two, so my X is going right here. As long as my numbers are from smallest to largest, I can use that in betweenness to figure out my shading. Otherwise, I do want to look at them side by one thing at a time. So interval notation at 7, it's going from -7. The shading part is going from -7 to 3. 7 had the open circle, so rounded bracket, and rounded parenthesis, and then 3 is the closed circle, which is the bracket. All right, changing colors just a little bit, just so that we can see them maybe a little bit better. All right, so the next one, I have 2 parts. I have an or in between it, so I'm going to look at one at a time. So the first number I see is a -3. And -3 with that inequality's got the line underneath it. It's x is less than or equal to -3, which means I am going to go to -3 and I'm going to put my closed circle because it's the or equal to. And now it's saying x is smaller, so less than. It's the x is by the pointier part, the smaller part. So this is going to go this way. Sometimes if I'll put my arrows right above the line. And then the next part, they're saying, okay, at 3, so at 3, I'm going to have an open circle because it's just x is greater than 3. When I'm looking at the x, it's by the bigger part of the inequality, so it is the greater than. I'm not a fan of using the, oh, it's pointing to the right. It works as long as you have the variable first, which we like to do if we can't use the less than when we're keeping everything smallest to largest. All right, so this time there is going to be a gap in here. So if I'm looking at it for interval notation, remember interval notation is always going to be the starting point of the shading to the ending point of any section of shading. So if I'm looking at the left side, I'm going from -infinity is where it's starting. Remember, -infinity always gets the parentheses. And that first part is going until it gets to -3. And -3 is a or equal to, so it's a square bracket. Now there is a gap in here. So when there's a gap in your graph, this is where I'm saying the union. So it's U is for union. It means that there is a gap. I'm combining both parts of my interval notation for my solution or my answer. And then I'm starting up again at 3 with an open circle, so rounded brackets, and it's going until infinity because it's just going off to the right, and infinities always get the parentheses. All right, so then if we're looking at the next one, it's written kind of weird, so we're going to see what we have. So this one, x is less than or equal to -7. So the number I see is -7. It is or equal to, so I'm going to have a closed circle. And x is less than or equal to it. So it is, oh, this is not that exciting. It is going to go to the left because it's less than or equal to a smaller point. Or, and then x is greater than or equal to 3. So I've got a closed circle at 3 as well. And x is greater than that, greater than or equal to. All right, so it's going to be similar to the one above, only we can mix and match those in the brackets and the parentheses, as we could see in that very first one. We could also have the same brackets on parts. So it's mix and match, your choice. What we're going to do, Alex, when you're working online, you will get to also choose which parentheses. I think when you're putting the answers in, you do have to pick which type of parentheses first, and then you get to put in your numbers. Or you can just type things in. It's a matter of if you like to click or type. Anyways, interval notation, I am going from -infinity all the way up to -7. That is an or equal to, so it's a square bracket. I have a gap, so that's the U. And then I'm picking it up again at 3, and this time it's a closed circle, and it's going to infinity, and there we go. So hopefully that'll help make a little bit more sense of the interval notation. You will have to use it for some of your answers, which is why it's included in the class.